Hello everyone, this is Einstein Group Lab number 28 and this is Series Connected Resistance. Objective: to verify the principles that govern resistance which are connected in series. Materials/apparatuses. Apparatuses PET Simulator. Circuit Construction Kit DC.
Procedure: in the lab experiment for the series and parallel connected resistances, we will use the FET simulator. To make the series circuit, we need to have the following materials: a switch, wires, a battery, resistors, ammeters, and voltmeters. Arrange the said materials in a way that the flow of the current is in one path, and for the parallel circuit, with the same materials that you have used in your series circuit, you need to rearrange your resistors in a parallel manner. To determine the value of your current that passes through the resistors and the voltages of each resistors, attach the voltmeter to your resistor, and for the total voltage of your circuit, attach your voltmeter to the corner edges of your wire.
So here is our table for our lab experiment. It consists of three different trials. So we have our resistance 1, our resistance 2, and our total resistance. Our current 1, current 2, and total current, our voltage 1, voltage 2, and our total voltage. So in our trial number 1, our R1 is 1 and our R2 is 5. So the total resistance of our trial number 1 is 6. According to our ammeter, our current 1 is 1.5 ampere and our current number 2 is 1.5 ampere, and our total current across the circuit is 1.5 ampere. So our voltage 1 is 1.5 volts and our voltage 2 is 7.5 volts and our total voltage is 9 volts. In our trial number 2, our resistance number 1 is 3, our resistance number 2 is 10, and our total resistance is 13. In our current number 1, our current is 0.69 ampere, and as well as in current number 2, and our total current is also 0.69 ampere. So our voltage 1 is 2.8 volts, that is the voltage on our resistance 1, and our voltage 2 is 6.92 volts, which is our voltage for our resistance number 2, which totals as 9 volts for our total voltage. So in our trial number 3, our resistance number 1 is 5, our resistance number 2 is 15. So our total resistance is 20. Our current 1 is 0.36 ampere, as well as our current 2 is 0.36 ampere, and our total current is also 0.36 ampere. Our voltage 1 in our resistance 1 is 1.8 volts, and our voltage 2 for our resistance number 2 is 7.2 volts, which totals for 9 volts. So here is the computation and how we got our total resistance. So because it's a series circuit, RT is equals to R1 plus R2.
Resistors are said to be connected in the series when they said DC chained together in a single line. Since also current flowing through the first resistor has no other way to go, it must also pass through the second resistor and the third, and so on. Then resistor series have commonly current flowing through them. As the current flows through one resistor must also flow through the others, as it can be only taken one path. The amount of current that flows through a set of resistors in the series will be the same at all points in the series resistor networks. Analysis. A resistor is not the only fundamental electronic component that can be used to convert a voltage to a current or a current to a voltage. But correctly adjusting its value, a different weighting can be placed onto the converted current and or the voltage, allowing it be used in voltage reference circuits and application. Resistors in the series of complicated resistors networks can be replaced by one single equivalent resistors R or independent Z, and no matter what combination or complexity of resistor networks is, all resistors obey the same basic rule as that defined by Ohm's law and Kirchhoff's circuits law.
As we observed in this lab this time, we carry out experiments about series resistors, that it can carry the same current but the voltage drops across them is not the same as their individual resistance values, that will create different voltage drop across each resistor as determined by Ohm's law. In series, they were connected one after the other. Components connected in series circuit is that if something happens to the one component, it affects all the other components. In short, when two or more resistors are connected together end to end in a single branch, the resistor is said to be connected together in series. Then the series circuit are voltage dividers. And if a circuit is broken at any point, no current will flow.
From the experiment we have done, we can conclude that the type of arrangement determine the value of variables resistor in the strong voltage electric current in the circuit. The series arrangement serve as a resistor voltage divider, which means if the voltage across the resistors is added together, then the amount is equal to the voltage source. Series resistors network, the individual resistors add together to given an equivalent resistance of the its combination of the resistors and its circuit can be interchanged without affecting the total resistance current or power to its resistor to its circuit and the output current of the other resistor. Therefore, the current is the same each resistor.